In this video, we will explore the exact pressures required by the R22 refrigerant in its most common applications. In addition, we will quickly analyze its thermodynamic behavior. R22 is a widely used refrigerant in freezing, refrigeration, and air conditioning systems. Although R22 is a highly efficient gas, its main disadvantage is its impact on the ozone layer and its high global warming potential, which is why it is currently subject to strict environmental restrictions. Next, we will observe its behavior at different evaporation temperatures. 1. Let's begin by selecting an evaporation or cooling temperature of -20 degrees Celsius in the simulator. This value is typical for equipment where the evaporator is used for freezing, such as for meats. 2. For a more accurate calculation, we will set the superheat to 3 degrees Celsius at the evaporator outlet. Remember, superheat is the temperature increase of the refrigerant gas inside the evaporator. The value of superheat varies depending on the system's thermal load. For example, in a freezer with a large quantity of food, the superheat may exceed 3 degrees Celsius, while with a lighter load, the superheat will be less than 3 degrees Celsius and can even reach 0 degrees Celsius when the load to be cooled is very low. 3. To calculate the condensation temperature within the refrigeration system, we will add 10 degrees Celsius to the outdoor ambient temperature of the equipment. For instance, if the outside temperature is 30 degrees Celsius, the condensation temperature will be 40 degrees Celsius. By the way, the video description contains the link to access this simulator. 4. Now, let's select a subcooling of 2 degrees Celsius. Subcooling is the decrease in the refrigerant's temperature when it is in liquid phase at the outlet of the condenser, which improves the system's efficiency. For example, if the external surface of the condenser is clean and the airflow is adequate, slightly higher subcooling values can be achieved. However, it is important to note that in warm climates or under poor heat exchange conditions at the condenser, such as low fan speed or dirt on the condenser coil, subcooling may drop below 2 degrees Celsius, even reaching 0 degrees Celsius. 5. The system pressure indicated by the gauge depends on the altitude above sea level. In this section of the simulator, we can select the altitude where the equipment is located. This allows for a more accurate pressure reading on the gauge, which is crucial in high-precision refrigeration systems. 6. For example, at sea level, the pressure values for a temperature of -20 degrees Celsius are as follows. 7. However, in another location, the gauge will display a different pressure. At 1,000 meters above sea level, the low and high pressures adjust to the values shown on screen. 8. For example, at 2,000 meters of altitude, the low and high pressures change according to the figure. 9. Let's check the pressure value when a temperature of -10 degrees Celsius is required at the evaporator, typical of refrigeration equipment. We can observe the low and high pressure values as shown in the figure. 10. For an evaporator temperature of 5 degrees Celsius, common in air conditioning systems, the low and high pressure values are displayed in the figure. On screen, we can observe the refrigeration cycle chart in the pressure enthalpy diagram for R22, known as the Mollier diagram. Remember that the link to use this simulator for free is available in the description of this video.